We are going to do some practicing with exponential growth. So here in the first one, which growth pattern in the table is exponential, and explain why? Well, remember, to have an exponential, we need to have a common growth factor. So with a common growth factor, you're really, for these it'd be easiest to take new divided by old. And when I look at the future row, and you can depend, but when I divide, I don't get a common growth factor. And so when you check the first one, new divided by old, you don't get a common growth factor, but you will see that they have a difference of 1.38, which means this one is linear. In this next one, if you check, now the growth factors, if you do new divided by old, they're all 1.6 something. So I guess if you're rounding, it might be right. But if you look at it, we would add 6, then add 9. Well, 6 and 9 is 15. 9 and 15, you add 24. There's just a nice adding pattern there, is what that one's all about. But so this is just pattern, I guess. It's not a whole lot of anything. But when you look at the last one and you take the new divided by old for each piece, you do get a growth factor with a ratio. I shouldn't use the word ratio. We use growth factor. With a growth factor of 2.5. So this last one, the Standardo, is a exponential because it has a common growth factor of 2.5. So for every one of these, if you multiply by 2.5, you get the next one. And that's why it is exponential. Now let's go to number 2. Let's suppose your company, which started a new web domain name of .math. It's been a year, and the word is out, and you're seeing growth. So you estimate the growth as being 80% per month since you began. That's your percent increase. At this rate, you're going to make money, $9.95 each for your domain names. You started this company a year ago with one domain name, you, in the first month. So how many domain names? We want an equation to do this. Okay, well, think about this. Y equals initial amount. I started with just me. 1 plus percent increase raised to the time. So I would end up with 1 times 1.8 to the x. And this will give me the number of users, right? Because I had the 80% increase, and 80% as a decimal is 0.8. Okay, so the growth factor, as we just said, is 1.8 because of the 1 plus percent increase. How much will you have made at the end of next month, assuming it's been a year? So we're saying that x is 12, but we're talking about money, right? How much will you have made? So if we talk about y equals 1 times 1.8 raised to the 12th, this will give us, we did approximately 1156 people, but the first one was you, and I don't think you paid for your domain name. So we had 1,155 paid domain names, and each one of those paid $9.95. So you end up with 11,400, is that a 9? Why can I not read my handwriting? Yes, it's a 9. 492.25. So just shy of $11,500 in that first year from the domain names. Now, if the growth continues, when will you make $1 million? Okay, now remember, when X was 12, you were at 11,492.25. So we need way more than that. So I'm going to start with 19. Let's say after 19 months, what's happened? So y equals 1 times 1.8 to the 19th. When I plug that in, I don't remember what I get, but then I'm going to multiply. Sorry, I have shorthand on my answer key here. I'm going to multiply, well, I'm going to subtract 1 to get rid of me, and then I'm going to multiply by 9.95. Right? Just like we did to find this answer, and I end up with 704,684.22. That is not $1 million. So let's go up 1. If I go to 20, y equals 1 times 1.8 to the 20th. Again, I'm going to subtract 1 from that answer to get rid of me, multiply by 9.95, and I end up with 1,268,439. So after 20 months from start, assuming that the growth continues at 80% a month, I will be over $1 million in how much I earned. Now, forget the money. When will I get 1 million users? Okay, so now we're just talking about just the straight formula. Okay, so remember, when I was at 12 months, I had 1,155 users. Okay, and I didn't do the math. I should have written that down. Oh, I did. I did for 20. For 20, I had 127,481 users. Okay, well that's still not enough. I want 1,000,000, not 127,000. So let's go up to 25. If I have 25, I have 1 times 1.8 to the 25th power. When I plug that in to the calculator, I get 2408865. Because you got to subtract one. Don't forget to subtract one for yourself. But that's over 2 million. I don't want 2 million. 1.8 is not quite doubling. So I'm going to go down to 24. And y forgot my 1 to the 24th power will give me 1,338,258. And so after 2 years, after 24 months, I will have at least 1 million registered users. If you go down to 23, you're in the 700,000. So you do need at least, into the 24th month to get your 1 million users. All right, let's go to an easier problem because that one kind of stinks. Number 3, the number of Facebook users doubled every 6 months starting in March of 2004, at which time there were 500,000 users. Growth factor. Growth factor is 2 because it doubled, right? When you doubled, you're multiplying by 2. What unit is time measured in? 6-month intervals. Right? It says that every 6 months. So when you have a value of x, that x represents a 6-month chunk. What's the exponential equation? Well, I started with 500,000 users, everything doubled, time period. And I use 0.5 for 500,000, knowing my answer needs to be in millions. Okay? All right. Estimate the number of Facebook users in March of 2007. Okay, in March of 2004, X was 0. This is 3 years later. Well, remember, X is in 6-month chunks. So the question you're asking yourself, how many 6-month chunks are in 3 years? Well, there's 2 per year, so I'm going to say X is 6. So Y equals 0.5 times 2 to the 6th, which gives me 32 million. So by March of 2007, we would estimate that we would have 32 million Facebook users. And the last problem, of course, it's got multiple parts. Consider the amount of money in the account below. Estimate the growth factor from year to year. Okay, well, the growth factor, remember, we can do that by taking new divided by old. I'm just going to take these last two because you know what? Why not? So 665 divided by 578.27 gives me approximately 1.15. And that, my friends, is the growth factor. So we can construct a model. Because where did we start? Well, if you look back, you started here at $250 with a growth factor of 1.15 to the x, where x represents the number of years since 2010, because 2010 is when we started. So 2018 would be 8 years later, so y equals 250 times 1.15 raised to the 8th power. Don't forget, exponent first, then multiply by 250, and you get 764.76. So we would estimate that in the 8th year, for that year, we would have 764.76. Now let's guess and check when we're going to have $1,000. Now again, we know that when x is 8, we're at 764.76. So it's going to be a little bit bigger than that. I'm just going to jump to 10. And when I plug in that for 10, y equals 250 times 1.15 to the 10th, I get $1,011.39. Has a horrible looking 1 0. So that's 10 years, so that would be in 2020, because remember, 2010 was our starting point. And that, I believe, is the end of the practice video.